Let's take our pre-calc 30 a little bit further than what we had just done. So section 1, we talked about characteristics of polynomials. Section 2, we talked about the remainder theorem. And in section 3, we're going to talk about the factor theorem. Well, the factor theorem is directly related to the remainder theorem. And it states that a binomial is a factor of a polynomial if and only if we can put the 0 of that polynomial in and it equals 0. In other words, we're saying the remainder equals 0. So if we can plug that 0 of this in and it comes out as 0, well, we have a factor. So let's check out these ones. Are they going to be factors of x cubed minus 3x squared minus x plus 3? So our question is, where does x minus 1 equal 0? Well, at x equals 1. So if we were to plug 1 into this polynomial, 1 cubed, subtracting 3, multiplied by 1 squared, subtracting 1, adding 3. Again, as I had said last day, I'm perfectly fine with you just plugging this in and finding out what it equals. I'm just going to go step by step. 1 squared is 1, multiplied by 3, negative 3, subtracting 1, add 3. Okay, it equals 0. So our remainder is 0, which means x minus 1 is a factor. Let's do it again. Let's do it for x plus 1. Well, where does x plus 1 equal 0? Well, that's at x equals negative 1. So if we were to plug negative 1 into this polynomial, does our remainder come out as 0? So negative 1 cubed, subtracting 3 multiplied by negative 1 squared, subtracting negative 1, adding 3. Going step by step. Okay, we get a remainder of 0. So that says that x plus 1 is a factor. Factor. I think that actually looks like that's written there. We can do the exact same thing on this one. Well, I don't have to write this equals 0 and solve it. I know that it equals 0 at negative 3. So we're going to plug negative 3 into this polynomial. So negative 3 cubed, subtracting 3 multiplied by negative 3 squared, subtracting negative 3, adding 3. Let's see, negative 3 squared or negative 3 cubed would be a negative 27. Negative 3 subtract multiplied by negative 3 squared should be a negative 27. Add 3, add 3. I believe it should come out as negative 48. Well, since our remainder is negative 48, that says that x plus 3 is not a factor. And last but not least, let's check out this one. What about if we plugged in positive 3? So 3 cubed, subtracting 3, multiplied by 3 squared, subtracting 3, adding a 3. So 27, subtracting 27, subtracting 3, adding 3. Yep, that comes out as 0. So that says that x subtract 3 is a factor. I've literally chosen these ones for 2 specific reasons. The first one is to say that, okay, x cubed subtracting 3x squared, subtracting x, adding 3 is legitimately x minus 1, which was the first one that we checked, multiplied by x plus 1, which is the second one we checked, multiplied by x minus 3, which is the fourth one we checked. If we remember back to our section 1, we talked about how that, because x cubed, is going to have to be an x multiplied by an x multiplied by an x. To get that constant term of 3, well, we'd have a -1 multiplied by a -1 multiplied by a -1. To get that highest power, we multiply by the first term, so the x's. To get that constant term, we multiply the constant term of each of our binomials. And it comes out as positive 3. The second reason that I chose those ones is for this numerical reason. And that numerical reason is the integral zero theorem. It states that if a binomial is a factor of polynomial p of x with integral coefficients, then a is a factor of the constant term. So what that's saying is if we want to say we have a binomial that's going to be a factor, all we have to look at is our constant term. We have to look at that 3. And we're going to look at the integral, or we're going to look at the factors of that constant term. More specifically, they're going to be the integral factors. So on this one, if we want to fully factor a 2x cubed minus 5x squared minus 4x plus 3, the numbers that we're going to check are the factors of 3. That's not too bad. 3 is not too bad. The factors of 3, so what numbers multiply give you 3? Well, that's 1 and 3. That's not all. Because we're going to be multiplying multiple things together, we are going to have to check out positive 1 and negative 1, positive 3 and negative 3. So for this one, we're going to have to check and see which one of these is actually going to work. So let's check each of our numbers. So if we plug, so for a, we're going to start off with a. We're going to factor this 2x cubed minus 5x squared minus 4x plus 3. Let's check 1. Can we plug 1 into our x's and get a remainder of 0? See, you can plug it all in your calculator. I'm going to show my work. 2, going to be subtracting 5, subtracting a 4, add a 3. We get a remainder of 4. Nope, doesn't work. Okay, so plus 1 doesn't work. Let's try out negative 1. 2 times by a negative 1 cubed, subtracting a 5, multiplied by a negative 1 squared, subtracting a 4, multiplied by a negative 1, adding 3. So negative 1 cubed is negative 1, multiplied by 2, that would be a negative 2, negative 1 squared is positive 1, subtracting a 5. 4 times negative 1 is negative 4, but we're subtracting it, so we're going to be adding it and adding 3. Awesome. So that equals 0. So we plug negative 1 in. That means x plus 1 is a factor. Why am I using x plus 1 when I use negative 1 in as my number to check in my polynomial? Because negative 1 is the 0 of this binomial. X plus 1 equals 0 at negative 1. So let's go back to our last day when we did our synthetic division. If x minus 1 is a factor, it means we can take our 2x cubed minus 5x squared minus 4x plus 3. Actually, I'll do that over here. 2x cubed minus 5x squared minus 4x plus 3, and it can be divided by an x plus 1. But long division, there's more room for error in long division. So let's do some synthetic. We do our coefficients and our constant term. 2, -5, -4, and +3. If x plus 1 is the factor, we're going to put, actually, I think I used purple last time, -1 in. I'm just going to write my addition sign right now. But I certainly am going to bring my 2 down. -1 times 2. -2. -5, add -2 is -7. -1 times 7. -7, sorry, it's +7. -4. Add 7 is a +3. -1 times +3 is -3. And -3 adding -3 gives us a remainder of 0. Which is exactly what it should happen. Our remainder was 0 here. Our remainder of 0 should be here as well. So this right here, we start at that x cubed. Well, we're going to drop power, 2x squared minus 7x plus 3. So we factored out that x minus 1 or x plus 1 already. We have a 2x cubed minus 7x plus 3. This is complex factoring. Let's factor this one. So I'm just gonna box this up. Let's factor our 2x squared minus 7x plus 3. So by a product and sum, product of 2 times 3 is 6, sum of -7. Yes, this is our crash course on factoring complex, just like we had factored some simple ones last day. Product of 6 and sum of -7 will be a -6 and a -1, which means we're going to split our -7x into a -6x and a -1x. 2x squared plus 3x. That just comes down, split her down the middle. 2x x minus 3. From these two, I'll want to factor a -1 so that I can get an x minus 3 again. Factor it out. X minus 3 and a 2x minus 1. So what that's saying is 2x cubed minus 5x squared minus 4x plus 3 equals x minus 3, 2x minus 1, and this x plus 1. We cannot forget about this. X plus 1. What this is also telling us is even though the -1 worked, if we had gone to the +3, because 3 is the 0, this x minus 3, it would have also come out as a remainder of 0. But the -3 would not have, because x plus 3 is not one of these factors. So this is it. this is our entire polynomial factored. We can do a quick check because we know that x times 2x times x is 2x cubed, and 3 can absolutely be determined by taking -3 multiplied by -1 multiplied by +1. Just to finish off our question, we're going to describe how to use the factors to determine the zeros. Well, we talked about zeros in pre-calc 20. What would we have to do here? We literally find the roots. We find out the zeros. We find out the x-intercepts. We just have to set each factor equal to 0. All of those would be, so we know where x minus 3 equals 0. That's 3. We know where x plus 1 equals 0. That's -1. We can also do this one in our head really nicely as a +1/2. Those would be our zeros, which is going to tie in nicely to our next section, but we're not going to have to worry about that right now because we're going to do some more factoring. We're going to fully factor this. Well, let's go back again to read our integral zeros theorem. It states a binomial is a factor if with integral coefficients, then a is a factor of the constant term. So let's look at this constant term. We have 36. Well, in order for us to find out what our factors are, we're going to have to look at the factors of 36. Those would be 1, 2, 3, 4, 6, 9, 12, 18, and 36. More specifically, positive and -1, positive and -2, positive and -3, positive and -4, positive and -6, positive and -9, positive and -12, positive and -18, and positive and -36. No, you will not have to check all of these, but you will have to check the ones that obviously make sense. I know that I'm not going to have to try out 1 because I can do that quickly in my head. I know that 1 to the power 4 is 1, 1 squared is 1, so I have to have 1 subtracting 13, adding 36. I know that +1 is for sure not going to work. Even -1, -1 to the power 4 is still 1. -1 squared is still 1. So I would still have +1 subtracting 13, adding 36. It's not going to come out as a remainder of 0. So a -1 also is not going to work. What I expect you to do is, if you can do it in your head, great. If you want to do it on your calculator, see what you want to do, great. But I expect that you show your work for which ones actually do work. So let's try this. Let's try 2. Will 2 work? 2 to the power 4, subtracting 13 times 2 squared, adding 36. If I just plug that into my calculator, squared, 36, I get a remainder of 0. Fantastic. Since 2 works, x minus 2 is a factor. So I'm going to literally factor out that x minus 2 right now. My coefficient from my x to the power 4 is 1. Since there is no x cubed, I have to make sure I put a 0 for that x cubed. My x squared is a -13. My x term, there is no x term, so I'm going to have to put a coefficient of 0. And my constant term is 36. I'm just going to make my box for my remainder. It should come out as a 0. So x minus 2 is a factor, so the 0 of that is 2. Oh, look there. That works out beautifully. So we have a 1. We're going to make sure we're adding. So 2 times 1 is a 2. 0 add 2. 2, 2 multiplied by 2 is a 4. Negative 13 add 4 is a negative 9. And 2 multiplied by negative 9 is a negative 18. 0 adding negative 18. Negative 18. 32 times negative 38 is a negative 36. We get a 0. So this is an x cubed plus a 2x squared minus a 9x minus an 18. Notice how I'm putting it over here? It's actually for a reason. So since this is an x cubed, we don't know how to really factor x cubes yet. There are some special x cubes that some of you will learn in calculus, but this one we can't really do. So we're going to have to apply this integral zero theorem with our factor theorem again. So 2 works. So we know that 2 works. Positive 2 works. There are some times that a positive 2 might work again. So 2 cubed, adding 2 multiplied by 2 squared, subtracting a 9 times 2, subtracting an 18. Let's see, so that's 8, adding 8, subtracting 18, subtracting 18. No, doesn't look like it. That looks like it's a negative 20. So if you would not necessarily have to even write that. So the positive 2 works, so it only works once. Darn it. Let's try out negative 2. The rule of thumb is I'll never really give you anything that you would have to go too far on. Usually, if it doesn't work within the first 3 numbers, you did something wrong. So, and I do mean like positive negative 1, positive negative 2, positive negative 3. If it doesn't work in those first 3 numbers, then you probably did something wrong, which is fine. You just got to go and find out your error. But let's do negative 2. Let's try out that one. Negative 2 cubed, adding a 2 times by a negative 2 squared, subtracting a 9 times by a negative 2, subtracting 18. So negative 2 cubed is negative 8. That's positive 8. Positive 18, negative 18. Well, that comes out as 0. This is something that you would show. I actually give you a mark for this. So you wouldn't have to show this one, but you would have to show this one. What this is saying is it's saying that x plus 2 is a factor. Now there is a specific reason that I wrote it over here. That's because I already have my coefficients of 1, 2, negative 9, and negative 18 right here. If I just make another L, I don't have to create more space. I don't have to even do a whole bunch more work here. I put the 0 here, which is that negative 2. And I can continue on right down here. I get my 1. I put my negative 2. There's a 0. I get it to put a 0 here because that's negative 2 times 0. Negative 9 adding that 0 is negative 9. And that becomes a positive 18. That last addition means we have a remainder of 0. Great. X plus 2 is a factor then. this one, because it goes down to an x squared, well, we can do it on the side. X squared, we have 0 x's. Subtract 9. Since we want to fully factor, we can factor things that have x squareds. What kind of factoring is this going to be? Hopefully in that silence, you said it's a difference of squares. Square root of x squared is x. Square root of 9 is 3. Make one positive, make one negative. So that's actually saying that if we had tried positive or negative 3, it would also come out as a remainder of 0. Well, that's fantastic. That's actually saying that our 4 factors are right there. We didn't even have to go anywhere close to these larger numbers. Final thing I like doing is fully factoring, which means actually writing down our original question factored. Let's go at the beginning. We could factor this x subtract 2 out. We can't forget that we have an x subtract 2. The second thing that we factored out was an x add 2. And our final 2 factors are this x add 3 and x subtract 3. And now we have fully factored this term. Nice word problem. Finish it off. A form that's used to make large rectangular blocks of ice comes in different dimensions, such that the volume of cubic centimeters of each block can be modeled by x cubed plus 7x squared plus 16x plus 12, where x is in centimeters. We're going to determine the possible dimensions in terms of x that result in this volume. Meaning, we're going to have to factor this. Well, what numbers are we going to check in order for us to factor? We're going to look at our factors of 12, which means we're looking at 1, 2, 3, 4, 6, and 12. More specifically, positive negative 1, positive negative 2, positive negative 3, positive negative 4, positive negative 6, and positive and negative 12. Which ones are going to work out great? Which ones aren't? Let's find out. Let's do some quick mental math. Will 1 work? 1 cubed is 1. 7 times 1 is 1. So 1 out of 7 is 8. Adding 16 times 1 is 16. Adding 12. Well, that's definitely not going to work. So you do not even need to write. Because we had already done that in our head. We do not even need to write any of that. We only need to really write the ones that work. But as a good practice, it doesn't hurt to write them down. So I'm going to do negative 1, and I'm going to write this one down. Negative 1 cubed, adding a 7 times by negative 1 squared, adding a 16 times negative 1, adding 12. Does that work? Let's see. That's negative 1. Actually, I don't like writing my equals over there. I like writing vertically. That's negative 1, adding 7, subtracting 16, adding 12. Well, that's definitely not going to work. Yeah, it comes out as a remainder of 2. So that's another one that if we just had used our calculator, you wouldn't even have to write this down. So let's try out 2. Well, I know for a fact 2 is not going to work. So I know that 1's not going to work. Negative 1, unfortunately, also didn't work. Positive 2, well, we'd have things cubed, and we're just doing a lot of addition here. So positive 2 is definitely not going to work either. Let's try out negative 2. So so this is what I do expect you to do, because I do expect you to write down that you are plugging negative 2 in. 16 times by the negative 2, 12. But I don't expect that secondary step. Negative 2 cubed, 7, being multiplied by the negative 2 squared, multiplied by 16 times negative 2. Yep. That comes out as 0. You get a mark for that. Literally, just put in your calculator. I'm good with that. So because negative 2 works, that means that x plus 2 is a factor. I'm writing this in a different color so we do not forget it. You need to make some note when you have these things factored that you're not going to forget. Alrighty. So let's factor this. We have 1x cubed, 7x squared, 16x, and a 12. The 0 of here is negative 2. I'm going to make sure I add things down and bring down my 1, write my negative 2, 5, negative 10 with that multiplication, positive 6, negative 12, remainder of 0. Well, since we started with an x cubed, this would be an x squared. 5x, add 6. We can factor x squareds. We can factor quadratics. Product and sum, product of 6, sum of 5. That's 3 and 2. So x plus 3, x plus 2. So this volume expressed in terms of x cubed plus 7x squared plus 16x plus 12 equals this x plus 2 and our last two factors of x plus 3 and x plus 2. It's going to be very beneficial for you to simplify this because there's two x plus 2's. Just write it as x plus 2 squared. And our examples are done. Have some fun.